Hey everyone, Tony Baccigalupo here with Bantam Tools. Bantam Tools makes desktop CNC machines with professional reliability and precision at an affordable price. And these things are wonderful. I just joined the marketing team recently. I come from the community world and I have very little experience in CNC machining. And so I am learning like crazy. And what I found is that this world is a world of stuff that maybe isn't the easiest thing to learn from the outside coming in. Even some of the 101 videos I found use a lot of terminology that I'm just not as familiar with. And so what I wanted to do was record a lesson that just walks through the entire process of CNC machining in a very, very clear, simple, straightforward way. So it's easier for you to understand if you're kind of new to it, or if you need to be able to find new ways to explain it to other people, maybe members of your family or students or something like that. So without further ado, I want to get into a presentation that I created to explain some of these concepts. This lesson is going to be focused on just the fundamentals of CNC milling, really getting you from the design to the actual manufacturing from a high level, what these concepts are. What I want to start with is simply, what is CNC milling? How do you describe this to somebody who doesn't know what it is? I like to think of it in relation to 3D printing. 3D printing is a pretty common thing that a lot of people are already pretty familiar with for the most part. 3D printing is something where you heat up a material and you actually create something from the bottom up. And so there's kind of this creation of something, and it comes from the bottom up, as opposed to CNC milling, where you're actually carving into a material. So 3D printing builds up from the bottom, CNC milling cuts down from above. So you can also think of words like drilling or carving or sculpting or machining. These things are all associated with the idea of milling something. And just put into simple imagery, think of creating an ice cream cone with soft serve where you're kind of pulling on the thing and it comes out and you're shaping something, versus something more like a sculpture where you're chipping away at an existing block of material. And the way that we do that chipping away is using this thing that's called an end mill. And an end mill, in my mind, is the easiest way I can describe it. Is it's a lot like a drill bit. Except with a drill bit, what we're used to with a drill bit is kind of something that just goes one direction. It goes in and out. That's what I would normally think of with a drill bit. Whereas a end mill goes not just in and out, but left and right and up and down. So it can move in all different directions, which allows it to cut in way more detailed and interesting ways. And so that's kind of just the main thing that we're using to affect the surface that we're going to be shaping. But the main thing that I want to talk about is the actual process of CNC milling start to finish. And what I wanted to do was just break down this process, because there's so many parts to it, so that it's really easy to understand kind of each piece. And then as we go, we can kind of get a little bit more comfortable and a little bit more attuned to how each piece fits into the equation and, kind of all the different parts that go into it. So, I'm going to start with these three general high-level categories, which is design, configure, and then mill. And so in the design world, we use this language of CAD, computer-aided design, which is to say it's like you're drawing something, but you're using a computer to do it so that it can be programmatically understood. So this is the what will it look like? And then there's the configure side, computer-aided manufacturing, or CAM, and that's where we're going to create the instructions that are going to be passed to the machine so that it knows how to make that drawing real. If you've got a drawing, it's there, but now the machine, we have to be able to tell the machine, well, how do I want you to cut into the material to make this image real? And there's a whole bunch of stuff there's a whole world of stuff within that, which we will get into. But the general idea is that there's going to be this phase where we're going to learn how to do that. So how is the machine going to do it? And then there's the machining. Let's get to it, which we're going to get to in a second. In terms of the software and the hardware involved with this, Fusion 360 is a very common piece of software that actually covers CAD and CAM. There's things like Inkscape, which is good for 2D, MaterCam, SolidWorks. Rhino 3D. There's a whole bunch of software on this side. And there's other ones, especially if you're just doing 2D. We'll get into some more of that at some point. And then on the CAM side, again, Fusion 360 handles this. Our Bantam Tools software handles this as well. And there's actually even some inherent SVG support. So you could actually, certain images, you could take them, drop them right into the Bantam Tools software and go straight, kind of skip the CAD process if you've already got that ready. And then on the mill, there's a whole bunch of different pieces of hardware that are out there. We produce the Bantam Tools desktop CNC milling machine, which of course we super duper recommend for these kinds of projects. Now I want to get into what we're actually doing. Well, we're using a mill, which is this machine that holds a piece of material and moves an end mill across it to cut into it. So in order to do that, we need material. And the material is something that is suited for this process of milling. And that could be wood, could be plastics, could be certain kinds of metal, or PCBs, printed circuit boards. And maybe other materials as well. There's a lot of different things you can do with these machines. These tend to be some of the most common. And then what we're going to do is we're going to cut into that material using a tool. And the tool is actually going to be the thing that does the cutting. That's the end mill. And that tool is going to spin around really fast. That's what's going to create that kind of kinetic momentum that's going to be able to break up this hard material that we're cutting into. And so that's how fast the tool is going to spin. And we can adjust that speed. So there's already a lot of nuances here, right? What kind of material are we using? How hard is it? How thick is it? How big is it? And then what's the tool? Is it thick? Is it thin? Is it strong? There's all kinds of different nuances to that. And then how fast are we spinning it? Then there's the feed rate. This is how fast we're going to move that end mill across the material. So it's spinning, but then it's also moving. And it's not just moving in one direction. It's also going down into the material. That's called step down. And then it's going kind of into the material along the top side of the material as well. So there's 3 dimensions that we're thinking about here. It going across the material, it going down into the material, and it going kind of into the material like a lawn, like when you're mowing the lawn, that you're going to be kind of edging through something from the top. This is all very detailed and nuanced. We will get into this some more, but I want to give you kind of the high level concepts of how all this works so that you have kind of a general vibe for it. And I want to do this in a very, very kind of clear way with color coding and icons so that we can start to demystify this a little bit. If you're totally new, we will get into the details of each of these as we go, but you can imagine how each one of these things kind of adds up to the whole process. So just to recap, we've got the computer. That's where we do our design, our CAD and our CAM, our design and configuration. And then we've got the mill, the physical mill, where we're going to do our thing. We're going to put a material in it. We're going to fasten the material to the surface. There's a few different ways we can do that with tape or with clamps or certain ways that we can kind of fix the material in there so it doesn't fly off. But we're going to save that for now. And then there's the tool that we're going to use. There's the speed that it spins around. There is the feed rate that it moves through the material. And then there's the step down where it digs down in, and then the step over in terms of how much of it cuts into with each pass. And that's the general overview of how it works in the simplest, most clear-cut terms possible. Now, once you kind of have the basics of that concept in mind, you can start to dive into the incredible nuances of every single one of these things. Because ultimately, being able to produce a project means being able to understand at least enough to be able to move through every step in this process. Now, fortunately, we're obsessed with this stuff. And so at Bantam Tools, we're constantly creating projects and formulas for being able to work with different kinds of materials at different speeds and feeds for different kinds of end mills, all of these different combinations that make for common recipes that you can use so that you can make your own projects without having to figure everything out yourself. So check out the resources we have at bantamtools.com, and in particular support.bantamtools.com, where we have our getting started projects and a couple of great resources to help you get started. And of course, check us out on all the social medias, Bantam Tools on basically all of the social medias. Lots of great resources, lots of inspiring projects for you. Hope this has been helpful for you, and stay tuned for more. Thanks very much for your time. I'm Tony Bacigalupo with Bantam Tools.